In this video, I'll be going through the iGCSE Paper 1 Additional Math from the 2024 November exam. So let's go through it. So in the second page of the paper, you'll be given the list of mathematical formulas which you can refer to during the exams. And also in this paper, you're allowed to use the calculator. So let's move on to question 1. So question 1 is a cubic equation or a cubic function question. So in this question here, you are told that the diagram shows the graph of y equals to mod fx, where fx is a cubic polynomial. So we know that if you have a cubic polynomial, okay, it will take this form, okay, y equals to ax cubed plus bx squared plus cx plus d. Okay, but later on I'll say this is not the form that we want because of the next sentence. So in the next sentence, you are told find the two possible expressions for fx in terms of linear factors with integer coefficients. So there are two things that they want, right? They want it in terms of linear factors and with integer coefficients. So that means they do not want this form here. Rather, they want it in this form. Y equals to k, x plus a, x plus b, and x plus c, right? This is the form they want. And they also say that they want a, b, and c are to be integers. Okay, so this is what we want. So they want us to express fx in terms of this. Okay, anything else that we need to know from this? Yes, they want two possible expressions. Why? This is because this is y equals to mod fx, right? This is y equals to mod fx. So a cubic curve will probably look something like this or like this. Okay, and if you're to mod this graph here, let's assume that this is the x-axis. If I were to mod this, it will look something like this, which is what we have here, right? If I were to mod this graph here, let's just assume this is the x-axis. Okay, it will look something like this. So I'll mod this, so flip it over, which will also look like this. So in other words, right, these two graphs, when mod, they will look like this graph here. So that is why there are two possible expressions. And the next thing we know about these two graphs are they are just the negative of each other. So if this is y equals to gx, for example, then this is y equals to negative gx. So they are the negative of each other. So in other words, right, the two possible expressions for fx are just the negative of each other. Okay, so now with that, let's do this question now. Okay, so we know that we want fx in this form. Okay, and because I need two possible expressions, and they are the negative of each other. So therefore, my final answer will be fx equals to plus minus k, x plus a, x plus b, and x plus c, right? So now let's first find a, b, and c, right? So I want a, b, and c. So in order to find a, b, and c, I know that they are basically the x-intercepts. Okay, so these values here will be related to this because when fx equals to 0, so your y is equals to 0, right? Y is equals to 0, right? So that means this k, x plus a, x plus b, x plus c is equals to 0. So therefore, x equals to minus a, minus b, or minus c, right? So therefore, I know that my a, b, and c, my fx is essentially plus minus k, x plus 4. I'll reverse the sign because here is minus 4, so I reverse it. Okay, so let me explain. So you notice that my x-intercepts occurs at minus 4, 0.5, and also at 2, right? So in other words, right, here would be x minus 0.5. Okay, then x minus 2 and x plus 4. Notice here's minus a minus b minus c. When I put here is plus a plus b plus c. So that means they are the reverse of the sign of the x-intercept. So if the x-intercept occurs at 0.5, then your x plus a is basically x minus 0.5. All right. Okay. So now I know that I have x plus 4, x minus 0.5, and x minus 2, right? Okay. Then the next thing is they want linear factor. So I cannot have 0.5 here. It is not a linear factor. So what would I do? I'll just multiply here by 2, right? Okay, this one I call it K1. This one I call it K2 then. It will be x plus 4. Then I multiply the whole thing by 2. It will be 2x minus 1 times 2 here times 2 here. So when you have 2x minus 1 equals to 0, you still have x equals to 0.5. Okay? X minus 2. Now, I need to find what is K2, right? So, I have this 24 here, which is to allow us to find what is this coefficient here. So, I know that when x is 0, f0 is 24, right? Mod f0 is 24, correct? So, I know that mod of this, so plus minus, so mod f0 is 24. So mod of k times 0 plus 4 times minus 1 times minus 2. How do I get this? I basically just sub in x equals to 0 here, okay? It's equals to, okay, sorry, 4. It's equals to 24, right? So I have 4 times minus 1 times minus 2, which is 8 here. So I know that k, so 8k is 24, so k is 3, right? So therefore, I know that my fx is equals to plus minus 3, x plus 4, 2x minus 1, x minus 2. All right, so that is the answer for question 1. Okay, now let's move on to question 2. So question 2 is indices question. Okay, so you're given that this times this equals to this. So in order to be able to combine these two together, 256 to the power of x plus y and 16 to the power of minus 2x together, we need to change them to the same power. Okay, so use your calculator to determine 256 is 2 to the power of what? So 256, if you use your calculator, okay, you can just do a trial and error. 2 to the power of 8. You can type it in the calculator. And we know that 16 is basically 2 to the power of 4. Okay, and then 8 is 2 to the power of 3. So I'm going to change all these to base 2. So 256 to the power of x plus y times 16 to the power of minus 2x equals to 8 to the power of minus x plus 3y. I just need to show y equals to 3x, right? So now I'm going to change this 256 to 2 to the power of 8, okay? Then times 16 is 2 to the power of 3, okay? 8 is 2 to the power of 3, 16 is 2 to the power of 4. Then 8 is 2 to the power of 3. Okay, so now let me look at this. So it's 8x plus 8y times 2 to the power of minus 8x goes to 2 to the power of minus 3x plus 9y. And from here, we know that if I have a to the power of x times a to the power of y, to combine that, it will become a to the power of x plus y. So I'm going to combine this. So this will be 2 to the power of 8x plus 8y minus 8x. So the 8x minus 8x will cancel off. I'll be left with 8y. Now both of them have the same base, so that means 8y must be equals to minus 3x plus 9y. So 8y equals to minus 3x plus 9y. So y is equals to 3x shown. Next, we are asked to hence find the exact solution of the following simultaneous equation. So I know that from this here, this is exactly the same as this here, right? So therefore, I can simplify this to y equals to 3x. So I'll label 1 and 2 from 1, comma. We know that y equals to 3x. Why? Is because from part A. Okay? So let me label this equation as equation 3. Now I'm going to substitute equation 3 into equation 2. So I'm going to put y equals to 3x here. So I'll leave x squared as it is. Then I'm going to change y to 3x. Okay, so this y changed to 3x. So now instead of 3y squared, it is 3 bracket 3x holding square. Now let's simplify it. So I have x squared. 3x holding square is 9x squared. 9x squared times 3 is 27x squared. So 28x squared gives me 56. So x squared will give me 2. And therefore x will give me plus minus root 2. Okay? Okay, I do not need to use the calculator to evaluate root 2 because the question asks for exact solutions. Next, when x is equals to root 2, y is equals to 3x, so it's 3 root 2. Okay, when x is equals to negative root 2, y is equals to negative 3 root 2. So these are the answers, okay, for part B. Okay, let's move on to the next question. The next question is a trigonometry question. Okay, so the diagram shows part of a graph fx equals to a cosine bx plus c, where a, b, and c are constants. Given that fx has a period of 960 degrees, find the values of a, b, and c. So for trigo, we know that for cosine, okay, so if I have cosine x, let me just write cosine kx. Okay, for y equals to cosine kx, the period, okay, is equal to 360 degrees over k. I'll use 360 instead of 2 pi for this question here because they give everything in degrees. Okay, if everything is in degrees, we'll just use degrees, so I'll be using this one here. So I know that the period is equals to 360 degrees over, this is not, for this question is b, so 360 degrees over b, and it is equals to 960. So what does this tell me? It tells me that 960 degrees times b is equals to 360 degrees. So therefore b is 360 over 960. 360 over 960. Divide by 6. So it is basically 3 over 8. Okay, use the calculator, okay, and it will just give you a fraction in its simplest form. So therefore, here I know that b is equals to 3 over 8. So now that I found b, I need to find a as well as c, right? Okay, so now how do I find a as well as c? Well, I already know that my maximum point occurs at 6, right? So let's do it. So, and I also know that, or I also can do it as when x is 0, y or fx is equals to 6, right? So I know that when x equals to 0 degrees, f 0 degrees is equals to 6. So if I will put in f 0 is equals to a, cosine 0 is 1, right? plus c, which is equals to 6. So this is one thing that I have. I can also do it here at minus 320. So I know that f 320 degrees is 0, right? Okay. So let me sub 320 degrees into this equation here. So I have a cosine 320 degrees times 3 over 8. I'll do it this way because I already know that b is 3 over 8. Okay, plus c, okay, is equals to 0. Okay, so type this into the calculator. So you have a cosine 120 degrees plus c equals to 0. And I know that cosine 120 degrees is negative half, right? Okay, so now that I have done this, I have two equations and two unknowns. I can solve for them. So I can just take equation 1 minus equation 2. So basically this is solving simultaneous equations. So I know that a plus, so from 1, I know a equals to 6 minus c. I call it 3. Sub 3 into 2. I'll have 6 minus c times minus half plus c equals to 0. So I have minus 3 plus 3 over 2c equals to 0. So 3 is equals to, so it's basically 3 divided by 3 over 2, right? So it's equals to 2. So just type it into your calculator, you'll be able to get this. Then I know that a is equals to 6 minus c, which is 6 minus 2, which is 4. So therefore, I know that a is 4, b is what we have found here, 3 over 8, and finally c is 2. Okay. Let's move on to question 4, which is an integration question. So if one look at this, I know that when I have an integration of ax plus b, it is equals to ln, 1 over a ln ax plus b plus c, where c is an arbitrary constant, right? Okay, but now I multiply here by 8, so I just bring the 8 outside and just multiply 8 by this entire thing. Okay, it's just like now if I have an 8 here, it's the same as putting the 8 outside because 8 is a constant. So the answer will just be this whole thing times 8. C is an arbitrary constant, so whether you times 8 or not, it still remains as an arbitrary constant. Alright, so let's do this question together now. Okay, so they want us to find what is a, right? So this is a definite integral, so we need to sub in the values. So let's do it. So I know that 8 4x plus 3 dx from 0 to 2a plus 1. Okay, I'm going to take out a. So 2a plus 1, 1 over 4x plus 3 dx. So integrate this, I'll get 1 over 4. So I put over 4 here. Ln 4x plus 3. And I need to sub in 0 and 2a plus 1 because this is definite integral. So 8 over 4 is 2. Next, I'm going to sub in x as 2a plus 1. So it will give me 8a plus 4 plus 3 minus, now I sub in x equals to 0, 3. Okay, so I have this ln 8a plus 7 minus ln 3. Okay, and I know that this is equals to ln 16, right? So what do I do? Well, I can just move this over. So I know ln 8a plus 7, and ln 16 is ln 2 to the power of 4, right? So it is the same as 4 ln 2. Okay, why I'm going to do this, I'm going to show you later. So I'm going to divide everything by 2, right? So this is 4 ln 2. So divide by 2 here and also divide here by 2. So this 2 is gone. Okay, so I'll be left with 2 ln 2. And 2 ln 2 is equals to ln 2 square, which is equals to ln 4. So I'm going to change it back to ln 4. Okay, now if I have ln A minus ln B, it can be simplified into ln A over B, right? So this is what I'm going to do. So this now becomes ln 8A plus 7 over 3. Correct? And A is equals to ln 4. So both of them are ln. So ln this equals to ln this. So that means 8A plus 7 over 3 is equals to 4. Okay? So let me erase this portion here. Okay. So I know 8A plus 7 over 3 is equals to 4. So just simplify. So A is equals to 5 over 8. Okay. Next, let's move on to question 5. In the expression 1 plus kx to the power 15, where k is a constant, the coefficient of x cubed is this. Find the value of k. So this question is a binomial expansion question, and the formulas for binomial expansion is given here. Okay. So now what do we have? We have 1 plus kx to the power of 15, right? So I have 1 plus kx to the power of 15. And I'm interested in the term with k with x cubed, right? So it's 1 plus, if you base it on the formula here, 15 choose 1, 1 to the power of 14, b to the power of 1. Okay? Okay, so it's basically 15 choose 1, then 1 to the power of 14, which is still 1, and then kx to the power of 1, right? But I'm not interested in kx. I'm interested in cube, right? So it would be 5 choose 3, 1 to the power of 12, which is still 1, kx to the power of 3 plus dot dot dot. Okay, so this is the term with the x cube. So I know that coefficient of x cube will be 15 choose 3 times 1 times k cube. And I know that it is equals to negative 29,120. So in other words, this is equals to minus 29120. So let's use the calculator to find what is 15 choose 3. So using the calculator, I know that 455k cubed is negative 29120. So basically, k is basically negative 29120 divided by 455. Then I cube root it. So let me just type all of this into the calculator. So I get k equals to minus 4. Okay, so the answer for 5a is minus 4. Okay, now let's move on to the next part. So find the term independent of y in this expansion. Okay, so I have 8y squared minus 1 over 2y to the power of 12, right? So the term, so the r plus 1 term will be equals to 12 choose r, okay, 8y squared to the power of 12 minus r times negative 1 over 2y to the power of r. You might be wondering how I get this. Okay, this is basically from the formula. Let me explain. So if you look at this, the binomial expansion here, this is the first term, this is the second term, this is the third term, and so on. So you know that this is the first term, this is the second term, right? So let's not look at the first term, although you can write it as n choose 0, which is just 1. Okay, then a to the power of n, b to the power of 0, which will still give you a to the power of n, right? So you know that if this is the first term, here is 0. This is the second term, here is 1. The third term here is 2. So for the r plus 1 term, this will be the formula. So this is the formula of the r plus 1 term of your binomial expansion. But actually it doesn't matter whether it's r plus 1 term or r term. Anyway, just write it so that it is just for expression. Okay, because we are not interested in which term it is, we are just interested in the term that's independent of y. Okay, so if I were to take a look at this question, okay, here. So this is 8y squared minus 1 over 2y to the power of 12. So I have 8y squared minus 1 over 2y squared power of 12, right? So my a is basically 8y squared. So if I'm looking at the r plus 1 term, which uses this formula, it will be 12 choose r, 8y squared to the power of 12, because the n is 12 here, minus r, then minus 1 over 2y, is it? Okay, to the power of, I think there's no square here. Okay, to the power of r. Okay, basically it's just making use of this formula here. Okay, so now let's go back to here. So I am interested in the term independent of y. So in order to have a term independent of y, the power of y is 0. So let's continue with this. So it's 12, choose r. So I'm going to separate the y from the numbers. Y 24 minus 2r. Okay. Then here I know that I can give minus 2 to the power of r. And here 1 over 2, y is the same as y to the power of minus 1. And I have y to the power of minus 1 to the power of r. So it's y to the power of minus r. Okay, so 12r, 8, 12 minus r. So I'm going to combine this term and this term together. So if you have multiplication, you will just add up the powers, right? So it's y to the power of 24 minus 2r minus r, so it's minus 3r. Okay, so now I want term independent of y. So I need the power of y to be 0, right? So when the power of y is 0, r is equals to 8. So now that I found this, I'm going to sub r equals to 8 in. Okay, so the 9th term is equals to 12, choose 8, 8 to the power of 12 minus 8, which is 4. Then I know that y is already power of 0 when I sub in r equals to 8, so I don't need to do it anymore. So minus half to the power of 8. So once I have this, just type everything into the calculator to get your answer. Okay, so I'm going to type this into my calculator. Okay, so I've So I'll get 7,920. Okay. Okay, so this is my answer, 7920. All right, let's do this question together. So the polynomial p is such that px equals to ax cubed plus 11x squared plus bx plus c, where a, b, and c are integers. It is given that p prime 0 is 12. It is also given that x plus 3 is a factor of p. When p is divided by x minus 1, the remainder is 16. You're asked to find the values of a, b, and c. So let's do this together. So in this question, there are three unknowns, a, b, and c. So because there are three unknowns, you need three equations in order to find them. So that is why there are three pieces of information given for us to form three equations. Now with that, this is a factor and remainder theorem, as well as some differentiation. So the first part is actually differentiation, because p prime basically means differentiation of p. So the first piece of information is p prime 0. So let's first differentiate px. Okay, so p prime x, so differentiate ax cubed give us 3ax squared, differentiate 11x squared gives us 22x, differentiate bx gives us b, and differentiate c, which is a constant, gives us 0. So this will be p prime x. So now we know that p prime 0 is 12, right? So therefore, when I sub in x equals to 0, I'll get 12. So I sub in x equals to 0 into p prime x, basically I'm just left with b. So I know that b is equals to 12. So I found b already, so I know that px is equals to ax cubed plus 11x squared plus 12x plus c. So with that, I need to find a and c. So I need two more equations. So from second sentence, since x plus 3 is a factor of p, from what we have learned from the factor remainder theorem, we know that p negative 3 will be equals to 0. So I'm going to sub in x equals to minus 3 into this. So I have p minus 3, which was equals to, okay, when I sub in x equals to minus 3 into x cubed, I get negative 27. Okay, so it will be negative 27a plus 11 times negative 3 squared, which is 9. Okay, then 12 times minus 3 is minus 36. Okay, sorry, plus c. Okay, so I have minus 27a plus 11 plus 99 minus 36 plus c equals to 0, right? So I have c equals to 27a minus 63. Okay, let me label it 1. Next, when p is divided by x minus 1, the remainder is 16. So when p is divided by x minus 1, remainder is 16. So from factor and remainder theorem, we know that p1 is 16. So p1, so I'm going to sub in x equals to 1 into this equation here. So I have a plus 11 plus 12 plus c equals to 16. So let me make c the subject, because I made c the subject in part 1. So I have 16 minus 23 minus a, right? 16 minus 23 is basically minus 7. Right? Yeah. 4 minus 7. Okay. So this is 2. I'm going to equate 1 equals to 2. So minus 7 minus a is equals to 27a plus, sorry, minus 63. So I have 28a equals to minus 6. Anyway, so I'm bringing this a over, so I'm going to bring this 63 over to this side. So 63 minus 7. Okay, so just type everything in the calculator. 63 minus 7. Okay, then divide by 28 gives me 2. So I know A is 2. Then from 2, right? C is equals to -7 minus 2, which equals to -9. Okay, so with that, I have found A is 2, B is 12, C is -9. So let me write it. Therefore, A is 2, B is, which I found it long ago, 12, and C is equals to -9. So this is my answer. Okay. Moving on to the next question, when e to the power 5x is plotted against x cubed, a straight line passing through the points this and this is obtained. So find y in terms of x. So I know that what it is this is a straight line graph, right? Chapter. So I know that my big Y equals to a big X plus C. So what do I have? I plot e to the power of 5y against x cubed, right? So this is my big X, which is x cubed, and this is my big Y. So I know that e to the power of 5y is equals to a x cubed plus C. Okay, so a is the gradient. So how do I find a? So a is equals to, let's find gradient, 9.84 and then 6.54, then minus this one here, 4.38, negative 2.56. So type everything into the calculator. So it's 0.6. So I know that the gradient is equals to 0.6. Next, I want to find the y-intercept. So how do I find the y-intercept? Well, I can do it this way. So I know that I have e to the power of 5y equals to 0.6 x cubed plus c. So I know that just use any of the points. So when x cubed is equals to minus 2.56, then e to the power of 5y is equals to 4.38, right? So let me sub in 4.38 equals to 0.6 times minus 2.56 plus c. So therefore c is equals to 4.38 plus this one, plus 0.6 times 2.56. So let me just type it into the calculator. So it's equals to 5.916. So now that I have found these values here, I know that I have e to the power of 5y equals to 0.6 x cubed plus 5.916. Okay, and everything is to 3 significant figures, right? So I can round off everything to 3 significant figures, or I can do it later, doesn't matter. Okay, so now what do I do? Well, I need to make y in terms of x. So I need to make y the subject. So if you have e to the power of 5y, to make y the subject, you need to ln both sides. So when you ln e to the power of 5y, you have 5y ln e. Ln e is simply 1, so it's 5y. So I ln both sides here, I'll have 5y, and the other side I have ln 0.6 x cubed. Okay, so therefore making y the subject, let me just erase this. Okay, so therefore y is equals to 1/5 ln 0.6 x cubed plus 5.92. Okay, I will round it off to 3SF for this value here, because everything here is to 3SF. Okay, so this is my final answer. Next, you are asked to find the values of x for which y can exist. So when they ask this, it has something to do with this portion, because we can only learn maybe k, where k is more than 0. In other words, 0.6x cubed plus 5.92 must be more than 0. Okay? For 0. So, sorry, 0.6x cubed plus 5.92 must be greater than 0. So, let me do 5.92 divided by 0.6 will be okay. So now that I have this, I need to find what is x, right? Or solve the inequality for x. So x cubed is equal to negative 5.92 divided by 0.6. So x must be greater than, I'm going to cube root this. Okay, so I'll get roughly negative 2.14 when rounded off to 3 significant figures. Okay, so that's my answer for B. Okay, now let's move on to question 8. So you're given that f prime prime x is this, f prime 1 is 6, f1 is 0, find f expression for fx. So basically you need to keep integrating until you get f, right? So if I have f prime prime x equals to 3x plus 5 to the power of negative 2/3, okay? In order to find f prime x, I need to integrate f prime prime x with respect to x. So if I were to integrate 3x plus 5 to the power of minus 2/3, okay, remember if I have integration of ax plus b to the power of n, where n is not equals to negative 1, then it will give me ax plus b to the power of n minus n plus 1 over n plus 1 times a plus c, where c is an arbitrary constant. Okay, but I know I'm going to integrate twice, right? So first time maybe I call it c, the second time maybe I call it b, and so on. Okay, so let's do it. So I have 3x plus 5 to the power of negative 2/3 plus 1 over negative 2/3 plus 1 times 3 plus c. Okay, so let's simplify it. So I'll have 3x plus 5 to the power of 1/3. Then 1/3 times 3 is 1. So this is basically that 3x plus 5 to the power of 1/3 plus c. Okay, and what else do I know? I know that f prime 1 equals to 6, right? So f prime 1 is equals to 6. So I know that 3 plus 5 to the power of 1/3 plus c equals to 6. So therefore I have 8 to the power of 1/3 plus c equals to 6. 8 to the power of 1/3, use your calculator, or it is basically just cube root of 8, which is 2. So c is equals to 4. So I know that my f prime x is equals to 3x plus 5 to the power of 1/3 plus 4. Okay, so now that I have found this one here, I need to continue to integrate again, right? So let's integrate again. So I'm going to get fx. Fx is basically integration of f prime x with respect to x. So I'm going to integrate 3x plus 5 to the power of 1/3 plus 4 dx. So integrate 3x plus 5 to the power of 1/3. I'm going to increase the power plus by 1. Then 1 plus 1/3 is 4 over 3. Okay, there's also this you need to put in. Then integrate 4, you get 4x. Now I'm going to plus c1. Okay, let me simplify this. So this one will give me 4. So it's basically 1/4 3x plus 5 to the power of 4 over 3 plus 4x plus c1. Okay, and I need to find c1, right? So that is why they give me f1 is 20. So I know that f1 equals to 20. So I'm going to start in x equals to 1 here. So it's 1 quarter. Start in x equals to 1 is 8. Is 1. Then 3 plus 5 is 8. To the power of 4 over 3 plus 4 times 1, which is 4, plus c1 is equals to 20. So use your calculator to solve for this one here. So let me type in 8 to the power of 4 over 3. 16 divided. So C1 is equals to 12. Okay, so now that I have found all this, I can move on to write the entire equation for fx. So they want an expression for fx, so I know that fx is essentially this, right? This whole thing here, but I need to put in c1 equals to 12. So it's 1 quarter 3x plus 5 to the power of 4 over 3 plus 4x plus 12. All right. Okay, now let's move on to question 9. The equation of a curve is this, where x is lesser than -1. Show that dy dx is equals to this, where a and b are integers to be found. So this is a division, so we need to make use of quotient rule. I'll use quotient rule because there's a square here, so I wouldn't change it to product rule. Okay, so I know that y is equals to e to the power of -3x plus 2 over x plus 1. So dy dx is equals to copy the denominator, differentiate the numerator. So differentiate e to the power of -3x plus 2 will give -3 e to the power of -3x plus 2. Then next, I'm going to differentiate the denominator. Differentiate x plus 1 gives me 1. Then I'm going to copy the numerator, divided by the square of the denominator, which is x plus 1 squared. So now I have this e to the power of -3x plus 2, right? So I'll factorize it out because this is what they want, right? So I'll factorize out e to the power of -3x plus 2, then over x plus 1 square. So when you're doing, right, always look at what you need to get, so that it's easier for you to move towards what you need. Okay, so now that I factorize out this and this, I'm left with -3x plus 1 minus 1, right? So therefore, I know that comparing this with this, I know my A is -3 and my B is -4. So that's the answer. Okay. Next, you are asked to show that there is only one stationary point on the curve and find its exact coordinates. Okay, so if there is only one stationary point, that means when dy dx is equals to 0, there's only one value of x. So when dy dx is equals to 0, e to the power of -3x plus 2 over x plus 1 square minus 3x minus 4 is equals to 0. So if I do a cross multiplication, okay, I'll have 3 e to the power of -3x plus 2 times -3x minus 4 equals to 0. Since e to the power of anything will be more than 0 for all real values of x, so only 3x minus 4 will be equals to 0. So x is equals to 4 over 3. So since there is only one solution for x when dy dx is 0, there is only one stationary point. Okay, so now that we have written this, the next thing we need to do is to find its exact coordinates, right? So coordinates, you must have both x and y. So I have when x is 4 over 3, we need to find what is y. So sub it into y. Y equals to e to the power of -3 4 4 over 3 plus 2 over 4 over 3 plus 1. Okay, so and they want exact, right? So let's give it as exact. So it's equals to e to the power of minus 2 over 7 over 3. So it's basically 3 over 7e squared. Okay. Hold on, now let me check. Did I make a mistake? X plus 1. Oh, sorry. It's not 4 over 3, it's minus 4 over 3. Yeah, minus 4 over 3. So I need to start in minus 4 over 3 here. So minus 4 over 3. Okay, so now let me erase this part. Minus 4 over, so this, okay, so I'll have e to the power of 4, e to the power of 6 over negative 1/3, so it's equals to negative 3e to the power of 6. Okay, so therefore coordinates, the coordinates that they are interested is negative 4 over 3 comma minus 3e to the power of 6. So this is the answer. Alright, so now let's move on to the next question. Okay, let's look at question 10. So question 10 is a GP question. Okay, so the third and the eighth term of a GP are 6 and 1, 4, 5, 8 respectively. Find the common ratio and the first term of the progression. So let A be first term and R be common ratio of the geometric progression. So we know that the rth term will be equals to the nth term will be ARn to the power of r to the power of n minus 1. So I know that the third term is equals to a times r squared, and it is equals to 6. And then the eighth term is equals to ar to the power of 7 is equals to 1, 4, 5, 8, right? Okay, so maybe instead of writing equals, let me use a semicolon instead. I'm going to label this 1 and 2. So I'm going to take 2 divide by 1. Okay, so when I take this divide by this, I'll cancel away the a, so I'll be left with r to the power of 5. Okay, use the calculator to solve for r. Which is equals to 3. Okay, so sub r equals to 3 into 1. So I have a 3 square equals to 6. So a equals to 6 over 9, which is equals to 2/3. So therefore, first term is 2/3. Common ratio, which is your r, is 3. Okay, so do note that the GP formula is here. So you can make use of these here. Okay, don't need to memorize. Okay. Next, the first 3 terms of a second geometric progression are cos theta, 2 cos square theta, 4 cos cube theta, where theta is in between minus 90 degrees to 90 degrees. Find the values of theta for which the geometric progression has a sum to infinity. So we know that the common ratio is basically the second term divided by the first term, or the third term divided by the second term. They'll be the same. So I'll just take this, the second term divided by the first term. So give me 2 cosine theta. Okay, next I want for sum to infinity to exist. Okay, this common ratio must be in between -1 and 1, right? That means cosine theta must be in between -half to half. But, okay, so if I were to look at the graph here, so I know that the cosine theta graph looks like this, right? Okay, and here it's x, here is y. Okay, and this is 0. So here is 90 degrees, here is -90 degrees, right? So this is y equals to cosine theta. So I want it to be in between -half and half. So let me, so I know that because theta is in between -90 degrees to 90 degrees, I do know that my cosine theta will always be positive. Is in between 0 and 1. So therefore it will never reach -half, right? So I can say that I'm interested in the values of theta where cosine theta is in between 0 and half, inclusive of 0. Okay, why I do not need to go to -half is because from -90 to 90 degrees, the cosine theta will never be negative. Remember your A, S, T, C, your 4 quadrants. So -90 degrees to 0 degrees is in the 4th quadrant where cosine is positive. 0 to 90 degrees, the 1st quadrant where cosine theta is also positive. So you'll never be negative. So the smallest value you can go when theta is in between -90 and 90 is basically 0. Cosine theta is 0. Okay, so if you look at this graph, I'm interested in from 0 to half, right? So let me mark out. So here is half, for example. So I'm interested in this portion and this portion, the x value for these portions here. So maybe let me highlight it. So I'm interested in this portion and this portion. And recall that half is a special value, right? So when when cosine theta is half, your theta is 60 degrees, right? So I know here is, this point here is 60 degrees, and therefore this point here is -60 degrees. Okay, you can also use your calculator. You take cosine inverse half, you get 60. Okay, so I know based on this graph here, so the theta, okay, range of values, so let me write required range of values will be from, theta is from -90 degrees, okay, and inclusive because I can include 0, but not inclusive of -60 because I want it to be lesser than half. Okay, or theta is from 60 degrees. Okay, I do not want to include half, right, because it's lesser than half, all the way to 90 degrees. Okay, so this is my range of values of theta for which the sum to infinity exists. Okay, oh, something to note, I do not want my R to be 0. Okay, reason is because when R is 0, everything will be undefined in your GP. So I do not want to include 0 here. So I will erase this. So because of this, not inclusive of -90 and 90 degrees. Okay, because recall that if you have sum to infinity is equals to A 1 minus R. So when R equals to 1, Yeah, I think we can include 0. Okay, but I don't want r equals to 0, because if I have r equals to 0, it will not be a GP. It will just be a constant term, or your GP will always be 0. So I also do not want to include 0. Okay. All right, let's move on to question 11. The diagram shows part of the curve y equals to 4 plus 2 sine 3x and the straight line AB. Okay, the point A and B lie on the curve. The x-coordinate of A is pi over 18. The x-coordinate of B is pi over 3. Find the area of the shaded region, giving your answer in exact form. So basically, to find the area of the shaded region is basically the top curve minus the bottom line. Okay, and integrate it from pi over 18 to pi over 3. And with that, you're given 9 marks. Okay, so let's do it. So required area. So pi over 18 to pi over 3. The top one is 4 plus 2 sine 3x minus line AB. But the problem is, do I have the equation of line AB? No, I don't. That is why it's worth 9 marks. So I first need to find the equation of line AB. If you don't want to find the equation of line AB, you can also find the area of the trapezium. It is the same. Okay, so let's do it when x is equals to pi over 18, y is equals to 4 plus 2 sine 3 pi over 18, which is pi over 6. 4 plus 2 pi over sine pi over 6 is half, so I have 5. So I know that here is 5. Okay, when x is equals to pi over 3, y equals to 4 plus 2 sine 3 pi over 3. Okay, so sine pi is 0, so this is equals to 4. So therefore, here it's 4, right? So let me call this area of trapezium. So to find the area of this trapezium, what I'll do is, I know that here is 5, here is 4. So these are the parallel sides, right? So it'll be half times the sum of the parallel sides, then times this height here. So to find this height is basically pi over 3 minus pi over 18. Okay, which is basically just 5 pi over 18 times 9 times half. So it is 5 pi over 4 units square. So trapezium. Okay, this is the trapezium here. So now you want to find shaded area. So let's do shaded area. So shaded area is basically equals to this area under the curve, right? So it's basically integrate 4 plus 2 sine 3x from pi over 18 to pi over 3, then minus the area of the trapezium. Okay, so integrate 4, you get 4x. Integrate 2 sine 3x, you get negative 2/3 cosine 3x. Okay, then I need to sub in these values as well. Then minus 5 pi over 4. Okay, so I'll have 4, sub in pi over 3, so into this. So I have 4 pi over 3 minus 2/3 cosine pi minus 2 over 9 pi minus 2/3 cosine pi over 6. Okay, minus 5 pi over 4. Okay, so let's use the calculator. I have 4/3 minus 4/3 pi minus 2 over 9 pi minus 5 over 4 pi. So I just type everything into the calculator. It'll be way easier. So that's what I'm going to do. Okay. Okay, so I have minus 5 over 36 pi. Then I have minus 2/3 cosine pi. So it's minus 2/3. Cosine pi is -1. Okay, then I need to plus 2/3 cosine pi over 6 is √3 over 2. Okay, so I have minus 5 over 36 pi plus 2/3 plus √3 over 3. √3 plus √3 over 3 minus. So this is my answer. So because they want exact form, don't need to type it into the calculator, just leave it as this. So the answer, the required area, which is this area here, is basically negative 5 over 36 pi plus 2/3 plus √3 over 3 units square. Alright, let's take a look at question 12, which is a trigo question. And in particular, it's solving trigo equations questions. Okay, let's take a look at this. You're asked to solve the equation 2 secant squared theta minus 5 equals to 5 cotangent theta for theta in between minus 180 degrees and 180 degrees. So in other words, right, let's take a look at the 4 quadrants here. Oops. Okay, so we have 4 quadrants here, A, S, T, C. So basically, if you are going from 180 degrees to negative 180 degrees, okay, it's only one cycle. Okay, so from here to here is 0 to 180 degrees, and then from here to here, when you go this manner here, it is from 0 to negative 180 degrees. So if the basic acute angle, which is in the first quadrant, or the angle in the first quadrant, when the angle is between 0 to 90 degrees, let's call it alpha. Then in the second quadrant, right, the angle will be 180 degrees minus alpha. In the third quadrant, it is because in the third quadrant, the angle is in between minus 90 degrees to minus 180 degrees. So it's basically negative 180 degrees plus alpha. And the fourth quadrant, the angle will be negative alpha. Okay, this is why we talk more about it in our A math lecture, so do refer to it, okay, on how to find the angles in the various quadrants. So now with that, let's take a look at this. I'm given 2 cosecant squared theta minus 5 equals to 5 cotangent theta. Okay, and I already know this theta is in between minus 180 degrees and 180 degrees. Okay, fine with that. So next, I have cosecant square and cotangent. So I do need to make use of an identity to change all of them to the same trigo form so that I can factorize it. So don't need to memorize, it's inside the formula booklet. Okay, we are going to use this one here. Cosecant square A equals to 1 plus cotangent square A. Okay, so let's do it. So I know that cosecant square A is equals to 1 plus cotangent square theta. So I'm going to substitute this cosecant squared with 1 plus cotangent square. So 2 cosecant square theta minus 5 equals to 5 cotangent theta. So 2 times 1 plus cotangent square theta minus 5 equals to 5 cotangent theta. 2 plus 2 cotangent square theta minus 5 cotangent theta equals to 0. I want to make everything, bring everything to one side so that the other side is 0 so that I can factorize. Okay, so I have 2 cotangent square theta minus 5 cotangent theta. 2 minus 5 is minus 3 equals to 0. So let's factorize it. I know that I have 2 cotangent theta and cotangent theta here. I have 3 and 1 here. So in order to get minus 5 cotangent theta, I have minus 3 here and 1 here. So 1 times cotangent theta gives cotangent theta. Minus 3 times 2 cotangent theta gives minus 6 cotangent theta. Minus 6 cotangent theta plus cotangent theta equals to minus 5 cotangent theta. Okay, so now that this times this equals to 0, that means either one of the brackets could be 0. So let me write it. So cotangent theta equals to negative half, or cotangent theta equals to 3. Okay, next, cotangent theta is equals to 1 over tangent theta, right? So why I need to change it to tangent? Because my calculator only has tangent. Okay, so let me change it to tangent. So I know that tangent theta is -2 and it is negative, right? So when it is negative, I'll be looking at the second and the fourth AST, here is T, here is C. So I'll be looking at the second and the fourth quadrant. For this one here, I'll be looking at first and third quadrant because tangent theta is positive. So now let's first look at basic acute angle of theta is equals to tangent inverse 2. So we always find basic angle first and ignore the sign. Okay. So using the calculator, I get 63.434 degrees, 63.434 degrees. So theta, because it is negative, so it's in the second or the fourth quadrant. So theta is equals to 180 degrees minus 63.434 degrees when it is in the second quadrant, or basically just negative alpha, which is negative 63.434 degree when it's in the fourth quadrant. So let me simplify it. So I get 116.6 degrees when rounded off to 1 decimal place, or minus 63.4 degrees when rounded off to 1 decimal place. Okay. Okay, now let's move on to this. Tangent theta equals to 1/3. 1/3 is a positive value, so I'll be looking at the first and the third quadrant. So let's first start off by finding basic acute angle. Okay, when tangent theta is equals to 1/3, it will give me tangent inverse 1/3. So it's around 18.434, is it 18.434 degrees. So because I'm interested in the first and the third quadrant, because 1/3 is a positive value, so in the first quadrant it is basically just alpha, or 18.4 degrees. The third quadrant is negative 180 degrees plus alpha, which is minus 180 plus 18.434 degrees. Okay, so round it off to one decimal place is 18.4, or 180. Wait, negative 180 plus 18.434, which is negative 161.6 degrees when rounded off to 1 decimal place. So let's write all the answers together, all the 4 answers together, starting from the smallest. So negative 161.6 degrees, followed by negative 63.4 degrees, then 18.4 degrees, then 116.6 degrees. So that is the answer for theta. Okay, let's move on to part B. We are asked to solve 3 sine bracket 2 plus. Okay, so let's go on to part B. So we are asked to solve these equations, and now instead of being in degree, you are in radian mode. So change your calculator to radian mode right now, and anyway it's the last question in the exam, so change it to radian mode first. Okay, all right, so with that I know I have this, and it is in between 0 to 5. Okay, but I'm going to do 2 of this plus 1.5. So this is in between 0 and 5. So 2 of this is in between 1.5 and 11.5. Okay, why I do this? Then I'll take 11.5 divided by pi, divide by 2 pi, sorry. Divide by 2 pi. So it's around 1.8. So I know that it probably goes roughly close to 2 cycles. So why I need to know this is because I know that I need to find 2 cycles. Okay, because 11.5 divided by 2 pi is around 1.8, which is very close to 2. So I know that that is going round in, so 2 pi is 1 cycle, right? It's going around 2 cycles. Okay, so now I know 3 sine this angle plus 1.5 is 2. So sine of it is equals to 2/3, right? So let's find basic acute angle of this. So because it will be sine inverse 2/3. Okay, let's use the calculator to find what is sine inverse 2/3. So it's 0.7 297 2, okay, radians. Okay, and 2/3 is positive, right? So in order for sine to be positive, I know that it's in the first and the second quadrant. So let's find these. So I know that it's equals to 0.72972. So this one is alpha. The second quadrant will be pi minus alpha. So I have pi minus 0.72972. And because remember I say it's roughly 2 cycles, so the next cycle will be 2 pi plus this angle. And for this one, I take 2 pi plus this, which will be 3 pi minus 0.72972. Okay? So now with that, let's first evaluate these values here. So I have 0.72972. Okay, then let me do pi minus this value here. Okay, so it's 2.41186. Then I'm going to do this. I'm going to take 2 pi plus this. Okay, 7.0. Finally, 3 pi minus this value here. Okay, to find the angle, I need to take these values minus 1.5, then divide by 2. So let me do it. Okay. This one is negative 0.385. I reject because it's not within the range from 0 to 5. Okay, so next I'm going to do this, the same for this. So I have 0.456 radians when rounded off to 3 significant figures. Okay, let's go on to this one here. Okay, 2.76 when rounded off to 3 significant figures. finally, let's do it for this one here. 8.6 9505 minus 1.5, then the whole thing divided by 2, I get 3.60 radian. Okay, let me check, are they all within the 0 to 5? Yes, they are all within 0.5, 0 to 5 except for this, so therefore the answer is 0.456, 2.76 and 3.60 when rounded off to 3 significant figures.